Hello everyone, welcome back. In this video, we will understand about the various programming constructs in C. These programming constructs are used to control the order or flow in which the instructions are executed. Programming constructs in C can be classified into sequences, selection, and repetition. Sequence, it is a very basic construct of writing a program, and the statements are executed sequentially in an order. For example, I have a declaration statement here, an assignment statements here, and a printf statements. Here, the instructions are executed one after the another. Selection. This provides the selection between the alternatives. A program can take certain route depending on a situation, and the selection statements help in choosing between the two routes. Let us take an example. In a factory, if an employee is present, then calculate the salary for 8 hours. Otherwise, do not calculate the salary and put 0. So depending upon the state of employee, whether he is present or no, you are asking the program to do one of the two things. A, when the employee is present, calculate his salary. B, when the employee is absent, put the salary as 0, and the processor will choose between taking a path A or path B, but not both. So here, how do we write this? So if his presence is greater than or equal to 8 hours, then salary is added. Otherwise, it is 0. So you have to remember one thing. This if statement is executed if the result is true. This is executed if the result is false. A repetition construct causes a group of one or more program statements to be invoked repeatedly until some end condition is met. So let us take the same example as before, but now I want to compute the salary of an employee for 20 days. Okay, so each day I check whether an employee is present for 8 hours. If he is present, then I update his salary. Otherwise, I mark his salary as 0. This has to be done for 20 days. So how will I do that? I will make use of a looping construct here. I will make use of a looping construct. The looping construct which I have used here is while. Okay, and for this I will check. I will have a test expression as days is less than or equal to 20. If it is less than, then I will compute his salary. Alright, so this goes on until this number of days becomes greater than 20. So here inside a while loop I have a test conditions. I have a if statement. Now what are the various constructs that the C provides? Selection, iteration, that is looping or repetition. Under selection we have conditional type and unconditional type. Under conditional we have if statement, if else statement, if else if statement, and a switch statement. Unconditional type, without any condition we can make jumps by using break, continue, and go to. In order to repeat certain instructions, C program provides us with for, while, and do while. Let us have a look at the selection or branching in this video. In our next video, we shall understand about iteration or looping. Before understanding the selection constructs, let us understand how the test expression is written. The test condition is used for selection and iteration. This is expressed as a test expression. Now, the test expression is true, which is 1, and false if it is 0. Now, for numerical expression, if it is numbers, any non-zero number is treated as true. For example, I have a is equal to 5, and if I put a into a test expression, this will be true, right? So for numeric expression, any non-zero value is considered to be true. Only if the variable is 0, it will be considered as false, right? The text expressions are formed in terms of relational expression or logical expressions, which is written in this format. So you can have a variable, expression, or a constant as the operands, and you can use any of the relational or logical operator right? Let us take few examples of the expressions. So a is greater than 2 is an expression. A is less than b plus c is an expression. A is equal to 3 is a test expression. A is not equal to 0 is an expression. A is less than or equal to b is an expression. A is greater than or equal to 2 is again an expression. However, whenever you are dealing with such expression, you should be careful, right? Let us take A is equal to 1 and B is equal to 2. Now when I perform this division operation, that is 1 by 2 plus 1 by 2, I expect the answer to be 1, but however this does not hold good because I am performing an integer by integer division. This will result into false. Similarly, whenever I am performing such comparisons, I should be pretty careful. Okay, let us take example of 5, 7 and 3. 5, 7 and 3. Now 5 is less than 7. This is performed first. This results into true, that is 1. 1 is less than 3. This results to 0. So avoid such expressions. You can break it down as A is less than B and A is less than C. You can have such type of expressions instead of writing it as A is less than B less than C. Now you have something called as short circuit execution of and or operations. In case of and operator, in case of logical and operator, this results to true only when both the operands are true. In all other cases, it results to false. So if the first operand is false, the second operand is never evaluated. The result is straight away false. Same thing holds good with OR also. OR is true when any one of the operators are true. If both the operators are false, only then it results to false. So in case of OR, if one of the operand results to true, the other operand is never evaluated, and these side effects will never happen. If the first operand is false in case of AND operator, in case of OR operator if the first operand is true. I mean to tell, this is how your C compiler evaluates the logical AND and logical OR. It just looks for the first operand to test its nature. If it is false in case of AND, the result of the expression will be false. If it is true in case of OR operator, the result will be true. Now let us understand about the selection or branching constructs. Now it is a basic construct to design a logical process. Selection is used to take decision between two or more alternatives, right? It is designing a program by choosing to execute one set of statements over others. You are not supposed to execute both the statements, you will be executing one among them. So this selection is also called as branching. You will be selecting one alternative among the two, right? Now this selection is classified into simple statements and multiple statements. Simple, we have a one-way selection and two-way selection. Multiple, nested selections, and multi-way selections, multi-way alternatives. Okay. One way, we just have one alternative to be chosen if some condition is true. So we have something like this. The syntax is if, small case if, condition, that is your expression. If it is true, execute the statement. Otherwise, you continue with the next set of statements. So the flowchart is test the condition. If it is true, execute a particular statement. Otherwise, you continue with the next statement. Two-way selection. We have two alternatives to be chosen. One among the two statements, that is either statement 1 or statement 2, but not both. We make use of two-way selection using if, else. Right? So the syntax is if followed with a condition. If the condition is true, execute statement 1. If it is false, execute statement 2. You have to remember here, the condition is only for if, you don't have condition for else. You test the condition once and decide which statement to be executed. So the flowchart goes as this. You check the condition. If it is true, statement 1 is executed. If it is false, statement 2 is executed. Consider an example of simple if statement here. So I read an integer from the user. Let us check if the number is negative, that is the number is less than 0. If the number is less than 0, you have to print the number is negative. After this if block, I just have another printf statement, the number is positive. Now you can observe in the output, I enter the integer as 10. Since 10 is not less than 0, the condition becomes false. I do not print this statement. I come out of the if block and print the number is positive. Again, check one more output, number is 0. Again the condition becomes false. I print the number is positive number. So if at all you have to print this number is a negative number, then the number should be less than 0. Take one more example to find the larger number. Here x and y are two variables which are assigned with 20 and 22 respectively. I check the condition x is less than y. Only if x is less than y, I will print the variable x is less than y. So since 20 is less than 22, the print statement which is there inside the if block gets printed. Consider an example for two-way selection, that is having if and else. I need to choose one statement among two alternatives. Take an example of checking whether an integer is odd or even. Ask the user to enter a number. Now if the number is divisible by 2, then we print the number is an even number. Otherwise we print it is an odd number. So if the user enters 10, since 10 mod 2 is equal to 0, this printf statement is executed. 10 is an even integer. Otherwise, take one more output. If the user enters 7, this condition becomes false. So the else part, whatever is there inside an else part, this statement gets executed. So 7 is an odd integer. Take one more example on two-way selection. A program to check if a person is eligible for voting. So ask the user to enter his age. If the age is greater than or equal to 18, then a person is eligible for voting. Otherwise, is not eligible for voting. Right? So ask the user to enter the age. If the user enters 20, then this condition becomes true. This becomes true. You print this statement and end of the program. Right? Now if the user enters 17, then this becomes false. You don't execute this statement. You straight away come here and print you are not eligible for voting. End of the program. So you have to remember one thing here. Either if statement is executed or else part is executed, not both. We can as well have a if block inside an if. Such a construct is called as nested if statements. Let us look at the flowchart first. So test expression for outer if, if this is true, we enter into an if block. Here again we have an if expression, when a test condition to be executed. If it is true, then we execute the statement with respect to this if block. Otherwise, we come out of the inner if block. Right? Now, if it is false, we execute the statement 2. Right? Let us look at the syntax. So, if test expression 1, inside this if block, we have if test expression 2. If this is true again, I execute statement 1. So, statement 1 is executed if expression 1 and expression 2 both are true. Otherwise, we execute statement 2. We can as well have a complete if-else block inside an if. So, this is the syntax for the same. So, I have test expression 1. Inside this if block, I again have test expression 2. So, statement 1 is executed. Otherwise, statement 3 is executed. So, you have to observe here, statement 3 gets executed only if expression 1 is true, but expression 2 is false. Okay. So, if expression 1 itself is false, then the else block is executed. Take an example of nested if statement, a program to find the largest among 3 numbers. I have declared 3 variables a, b and c to store the 3 numbers. Now I check if a is greater than b. If this is true, I check a is greater than c also. If this is true, then I'll print a is the largest number. Otherwise, I print c as largest number. If this is false, I come to the else part and check if b is greater than c. If this is true, I print b is largest, otherwise print c is largest number. Let us run the program and check the output. If the user enters the values 4, 5, 6, right, a greater than b, this condition is false. So it goes to the else part. Inside else part, I have b is greater than c, that is 5 greater than 6. This is again false. So this statement gets executed, that is c is equal to 6 is the largest. Take one more example, 7, 5 and 4. A is equal to 7, B equal to 5 and C equal to 4. A is greater than B, 7 is greater than 5. Condition is true. A is greater than C, that is 7 is greater than 4. The condition is true. You print A is the largest number. Take the third example, 1, 6 and 2. A is equal to 1, B is equal to 6 and C is equal to 2. So straight away this if block is not executed. You come to the else part. So 6 is greater than 2. Condition is true. You print B is the largest number. One more multi-way selection is using if-else ladder. So we have a series of if-else statements in this case. So let us look at the flowchart first and then look at the syntax. So I have a test expression 1. If this results to true, statement 1 is executed. If it results to false, I check one more condition. Expression 2. If this results to true, I execute statement 2. If it results to false, I test for expression 3. If this results to true, I execute statement 3. If it results to false, I execute statement 4. Right? Let us look at the syntax now. If test expression 1, if it is true, statement 1 is executed. Else if I check the second expression. Look at the syntax here. I have else followed by a space, then if, then I have a condition. Right? Statement 2 is executed if it is true. If it is false, I check another expression, expression 3. If true, I execute the statement. Else, final else, I execute statement 4. Right? So you have to observe one thing here. I had expression 1 checked with if. expression 2 with else if. Okay, expression 3 with else if. Finally, in an else if ladder, the final statement should be else. Okay, take an example of if else ladder. Program to find nature of a number, that is check if a number is 0, positive or negative. Right? So I declare a variable a to store a number. See if a is greater than 0. If a is greater than 0, you print the number is positive. Else if the number is, if a is less than 0, print the number is negative, else the number is 0. So you have to observe one thing here. Either of these three statements will be executed. Either of these three statements will be executed. So first you check with this condition. If this is false, you check with this condition. If this is also false, you print this statement. Now if at all this is true, if this is true, you straight away print this statement and come to the end of the program. You skip the remaining conditions and the else block. Let us take an example. Read a number from the user. If the user enters 10, now 10 is greater than 0, the condition is true, you print the number is positive. The remaining two statements are not printed. The remaining statement with respect to the else blocks are not printed. Take one more output. So enter a number, ask the user to enter a number. If the user enters minus 20, so this is false. In this case, this is false. A is greater than 0 is false. This is true. So you print this statement. Okay. However, you do not print this statement. You come to end of the program. Right. Now one more output. So if ask the user to enter a number, if the user enters 0, now here this is false. This is also false. So you come to this point and print the number is 0. Now, whenever we have such nested if-else statements, we encounter a problem called a dangling else. This is a problem which occurs whenever there is no matching else for each of the if. Right? So to avoid this problem, the compiler follows a very simple rule. It always pairs the else with the most recent if in a current block. Let us take an example. I have if condition, that is expression A. I have a nested if expression B. If this is true, execute BT. Now I have this else statement actually for this if, okay, but however what your compiler does is it matches this with the most recent if, because we did not write this else appropriately, right? So this is called as a dangling else problem and we should be very careful with it. How to avoid such problem? One way is to use a null else statement, that is inside if at all we have one more if statement and an else statement, you use a null statement for an else, or best thing is to make use of the braces, to make use of the block statements. So for this if I have this particular block, for else I have this block. This is a better way of avoiding dangling else problem, right? Another multi-way selection is using switch statement. Again, the switch statement helps us to choose an alternative among multiple available alternatives. So first we'll understand with the flowchart and then we'll go with the syntax. So here the switch statement, it compares the expression with the case constant. If it is true, we here check for equality. If it is equal, if it is true, statement list 1 is executed. After executing the statement, the control comes out of the switch block. If this is false, if the expression is not equal to constant 1, the expression is compared with the next constant. If it is true, statement list 2 are executed. After executing it, you come out of the switch block. If it does not match, if it is false, you check with constant 3, compare expression with the constant 3. If it is true, statement list 3 are executed. After executing, come out of the switch block, and so on. Finally, if the expression does not matches with any of the constants, okay, a default block is executed. A default block is executed with the statements corresponding to a default block. After executing, again you come out of the switch block. The syntax for the same is, so switch expression, you have case, constant 1, statement list 1. In order to come out of the switch block, we make use of break. For the second case, constant 2, statement list 2, come out of the switch block. Case, constant 3, list 3, come out of the switch block. Default, if none of the case constants matches with the expression, default is executed, wherein we execute a corresponding statement. So this is the syntax for your if statement. Now, few things to remember with switch statement. It evaluates the expression and looks for a matching case label. If none of them is found, then the default will be used. Now, there is no hard and fast rule to include default in your switch case block. If at all you don't have, you simply come out of the switch block. One thing to remember, the case constants, they must be an integer or a character constant. You cannot have floating point numbers there. The expression, when used in a switch block, it should evaluate to an integral type. Okay. Now, whenever we are using character constant, they must be enclosed in a single quotes. Right? Switch statement. Whenever we are having a default case, if it is present, it will be present at the last. Okay. Again, as told previously, there is no hard and fast rule to include this default. Okay, but usually it is a good programming practice to include one. Now, some points about the break statement. Now, switch cases do not break automatically. You should bring the control out of the case. For that purpose, we make use of the break statement. Right? Now, the break statement must be used within the case. If at all you do not want the control to execute the next subsequent cases. Now, whenever we make use of this break statement, the C executes the next statement outside the switch construct. So, as a summary, the switch statement enables us to choose one of the action among the set of possible actions based upon the result of an integer expression. The case labels can be in any order, but they must be constants. No two case label can have a same value. Okay. The default is optional and it can be put anywhere in the switch construct. However, the good programming practice is to put the default at the end. The case constant must be an integer or a character constant. The expression should evaluate to an integral type. The break statement is optional. Okay. But if you omit the break in any of the cases, the program flow is followed through the next case label. Okay. Now, there are few differences between if-else ladder and the switch. In case of switch, we test only for equality, but in case of if conditional expression, we make use of any of logical or relational operators. Right? A switch statement is usually more efficient when compared to your nested if-else statements. A switch statement can always be replaced with a series of else if statements. Okay. Now, we can use a switch and a case statements if an expression is required to check against a finite amount of constants, integral or character values. If there are too many values and if any of the values depends upon the variables, or if the values are not integer or characters, then we have to use else if statements. Okay, even when one can use switch efficiently, it's just a matter of personal preference. In whichever way I am convenient, I can break down the problem and write my program using a switch or an else if statements. Let us look at few examples on switch. Consider an example of switch statement using character constants. Now this is a simple program to check what choice the user has entered, whether he has entered A or B, right? So I design my switch block. By passing the character constant. I've stored this character constant into a variable called ch. Right? Now always the character constants are put inside a single quote. Okay? So case is a keyword. The constant, character constant, put inside a single quote. So if at all the user has entered A, you print the user has entered A and break. Basically this break brings the control out of the switch block. Right? If the user has entered B, so ch gets matched with B, you print the statement you entered B and break, again it brings the control out of the switch block. If the user does not enter anything, for example he enters null, then you print illegal entry and break. Right? So consider the output here. Here the user has entered A as an input. So what happens here? Ch has the value A. This gets compared with each of the case labels. So A gets matched here. You print you have entered A. You have a break statement. Come out of this switch block. After the switch block you have written 0, that is end of the program. Consider one more. If the user here has entered B, so B, it gets compared with A, is not equal to B. So now B gets compared with the second case, it is equal to B. So you print the user has entered B, come out of this switch block using break. Now in the third case, the user has not entered anything, he has simply hit an enter. So enter is basically a new line character which is an illegal entry. That means it does not match with any of the case label. So automatically your control comes to the default block. You have a statement here, print illegal entry, come out of the switch block. This break statement for a default is optional again. You can include or you can avoid it, because immediately after a default we have end of the switch block. Consider a switch statement without a break. Now what happens if we do not include break statement after each of the cases? Now here I have declared a variable I which is initialized to 2. Now I pass this I to the switch. Now here I gets compared with each of the case constants. So there is a match here. So you print case 2. Since I don't have a break statement, the execution follows. So I have printing of case 3, printing of case 4, default and end. So you can just see the output here. Case 2 is printed, case 3 is printed, case 4 is printed and a default gets printed. Hope you all have understood all the concepts with respect to selection or branching. In the next video, we shall understand about iteration. Thank you.